Abstract. Organic chemists often make their own reactants to have some control over the reactivity. In this video, a trans-cinnamic is brominated through an anti-addition mechanism to yield a vicinal dibromide. Trans-3-phenylaryl acid was oxidized with hydrobromic acid with hydrogen peroxide and ethanol to produce 2R3S2,3-dibromo-3-phenylpropanoic acid and water. Solid trans-cinnamic acid was dissolved in ethanol and then condensed through reflux distillation with 30% hydrogen peroxide. After crystallization, the percent yield was found to be 2.98%, while the infrared spectroscopy was not as accurate as expected due to traces of isopropanol when tests were conducted. The NMR spectra for H1C13 and depth 135 were consistent with the intended structure. The percent yield was extremely low, which could be due to inefficient drying and recrystallization process. Introduction. Bromination of an alkene is an addition reaction in which the bromine acts first as an electrophile with the alkene and then as a nucleophile attacking a carbon of the three-membered ring. The resulting vicinal dibromide then undergoes an SN2 reaction, which results as an overall anti-addition product. This bromination can be executed through several different methods. However, solvents such as methyl chloride and pyridinium tribromide can be extremely dangerous, and their reactions produce unneeded waste. Therefore, a more green method of bromination, utilizing hydrobromic acid and hydrogen peroxide to form dibromide with a byproduct of water, is the suggested reaction in recent literature. When comparing the three reaction types, it is essential to take into account factors such as atom economy, E factor, and effective percent yield. Based on the table by Mackenzie of a similar reaction of trans-stilbene, the most dangerous reaction involving the suggested carcinogenic methyl chloride gives 100% atom economy, or how efficient the method is in producing the intended product. The much safer option, using hydrobromic acid and hydrogen peroxide, is close behind with a 90.4% atom economy. Looking at the E factor, the methylene chloride shows to produce the least amount of waste, although it is through the use of a dangerous solvent. Environmental impacts is best measured through the effective mass yield because it incorporates the relative hazard. The hydrobromic acid-hydrogen peroxide reaction is shown as yielding the highest percentage of an effective mass yield at 71.8%. To confirm the formation of the 2R3S2,3-dibromo-3-phenylpropanoic acid, it is essential to run infrared spectroscopy, known as IR nuclear magnetic resonance, NMR tests, and an IR of the reaction with hydrobromic acid and hydrogen peroxide, which show the CH bonds around 1600 to 1400 centimeters to the negative 1, and the carbon-bromine bonds with a peak around 950 to 500 centimeters to the negative 1. The carboxylic acid stretched in the intended product would also be seen between 1760 and 1690 centimeters to the negative 1 for the carbon double bond with oxygen, and 1320 to 1000 for the carbon oxygen single bond. NMR graphs should have two doublet signals in the proton H1 graph for each carbon with the hydrogen. These signals would not overlap because they are in different environments. There would also be one singlet that corresponds to the OH on the end of the carboxylic acid. The phenyl ring would produce singlets and doublets, depending on the carbon. Carbon 13 in depth 135 will show 4 signals for each carbon in a different environment. The depth 135 should have only up signals because all carbons are carbons bonded to a single hydrogen. Again, brominations such as this and other reactions that result in a product that will be further tested upon are extremely useful to organic chemists. The ability to create your own reactant gives the scientist the ability to oversee and manipulate factors such as reactivity and creation that they would otherwise not be able to control. Further, the development of more green and environmentally conscious reactions is also possible when chemists are able to produce their personal reactants.
The flask was removed from heat and allowed to cool to room temperature. Once cooled, the solution was neutralized using concentrated sodium bicarbonate to a pH between 5 and 7. Once neutralized, the flask was placed on ice to allow for more crystals to form. Vacuum filtration was performed using ethanol to coat the filter paper and cold water to rinse the flask. Once the product dried, percent yield and melting point were then obtained. Results: 0.502 grams of trans-cinnamic acid was obtained to begin the experiment. Reflux was begun at 94 degrees Celsius. Hydrogen bromide was added and the solution went from a clear color to a cloudy white. Then 30% hydrogen peroxide was added to the mixture and the color went from a cloudy white to a brown amber. Concentrated sodium bicarbonate was added to the mixture of a pH of 2 in order to neutralize it. The final pH obtained was about 6.4. At this point, no precipitant had formed in the flask. Once the solution was allowed to cool, a white-colored precipitant started to form. According to the theoretical yield, there should have been 1.039 grams of product obtained at the conclusion of the experiment. According to the percent yield, only 2.98% was obtained with a weight of 0.031 grams. When a melting point range test was performed, the product did not melt even when the temperature exceeded 300 degrees Celsius. Figure 1 displays the IR of the obtained product, which did not contain functional groups present in the target product. Figure 2 displays the proton NMR of the obtained product. Present are 3 peaks, a doublet, and 2 singlets. The 2 singlets on the outskirts of the NMR is the solvent, used chloroform B, with a chemical shift of negative 0.006 and 7.258. Figure 3 displays an enhanced view of the middle proton, the doublet present, which has a chemical shift of 1.551. Figure 4 displays the carbon-13 NMR of the product obtained, which only displayed the signal from the solvent used. Figure 5 displays the depth NMR of the product obtained, which also only displayed the signal from the solvent used.